Welcome to the lecture number 1. What are vectors? In this video, we are going to discuss the different types of vectors, the definitions, and some properties of vectors. And after that, we will discuss about the vector algebra. So, what are the contents of this lecture? In this lecture, we are going to discuss about vectors and scalars, means the definitions of vectors and scalars, how the vectors are represented graphically and analytically, what are the different types of vectors, how do we add vectors using parallelogram law and triangle law, how do we subtract two vectors, what are these unit vectors I cap, j cap, k cap, what is the meaning of components of vectors and how do we find the components of vectors, what are direction cosines, what is a scalar product and what is a vector product, and then after that we will look at some solved examples based on vector algebra. So please watch the full video. First question, what are vectors and scalars? What is a vector and how it is different from scalars? Definition of vector is this: a physical quantity which can be described by both magnitude and direction are called vectors, whereas those physical quantities which can be described fully by magnitude only are known as scalars. So in physics there are lots of physical quantities and some of them depend on direction. For example, force has a direction, velocity has a direction. But some other physical quantities like temperature doesn't have direction. So temperature is a scalar. Pressure also does not have any direction. Pressure is a scalar. Work done is a scalar. Energy is scalar because energy has no direction. But force has direction, so force is a vector. Velocity has direction, so velocity is a vector. Let us look at the list of some scalars and vectors. You might have already studied that displacement, velocity, acceleration, momentum, force, these physical quantities are vectors. In the class 11 syllabus, you will study some new type of physical quantities like torque, angular momentum, and in 12th class you study about electric field, current density, magnetic field, etc. These are all vector quantities because each of these are associated with direction. Whereas these quantities like mass, length, time, they do not have any direction. Distance has no direction, speed has no direction, work has no direction, power has no direction, energy has no direction. So these are all scalar quantities. Here energy includes all types of energies: kinetic energy, potential energy, heat energy, sound energy, etc. We will also study in the chapter known as rotational mechanics a quantity known as moment of inertia, which is also scalar. Stress is a scalar, strain is scalar, pressure is scalar, temperature is scalar. In 12th class syllabus you will study about electric charge and electric current. These are all scalars. Electric flux, magnetic flux, these are all scalars. One interesting point is about electric current. Electric current has a direction. When current flows in a wire, then the current has a direction along the wire only. But still, electric current is not considered as a vector because it is found that electric current does not add like vectors. It doesn't obey the mathematics of vectors, or it doesn't obey the vector algebra. Now let us see how do we represent vectors. When we write notes in paper, then we can represent the vectors either by graphically by drawing arrows or analytically. Analytically means mathematical equations. So when we write vectors in the mathematical equations, we use symbols like this. We can take alphabetical letters A, B, C, D, E, F, any letter can be taken and we put an arrow over it. whenever any letter is represented with an arrow on the top of it, it means it is a vector quantity. Okay, so this represents a vector quantity. We can use the capital letter or we can also use the small letters. Here we have another type of symbol which looks like a cap or a hat over the letters. These are also some types of vectors about which we will study later. And graphically means we have to represent it by drawing. So it can be drawn like an arrow. An arrow also has a head and tail. So vector has a head and tail. Now the question arises that in which direction we have to draw these arrows. So it is very obvious that in whichever direction the physical quantity is acting, the vector is drawn in the same direction in which the physical quantity is acting. For example, see this picture here. In this diagram, the car is moving along the x direction, positive x direction. So if the car is moving in the positive x direction, then the velocity, this v with the arrow represents velocity vector. Velocity vector of the car must be directed along the x direction, in which direction it is moving. This velocity vector can have magnitude, any magnitude 10 or 20 meter per second. So first of all, in which direction we should draw the vector? The direction in which that physical quantity is acting. Secondly, so for example, you see, if a car is moving along the positive x direction, then its velocity vector will be drawn in the same direction. Next point, the length of the arrow must be proportional to the magnitude of that physical quantity. Example, see here we draw the arrow. How long we should draw the arrow? Small or big? So it depends upon the magnitude. Let us say in case 1 the velocity is 10 meter per second. So we choose some scale. Okay, let us say we draw it 1 centimeter or 2 centimeter length long. Okay, let us say this much amount of length represents 10 meter per second. So if I have to represent 20 meter per second velocity, that will double, then I should draw a vector of double length. So while solving problems, when we draw the graph or when we draw the diagram graphically when we draw the vectors, then we should take care that the length of the arrow or the vector that we draw must be proportional to the magnitude of the quantity which it is representing. Now how do we represent the magnitude of the vector? By using this symbol mod. This two vertical lines drawn around the vector we pronounce is at mod of A. So here A is the vector and mod of A means magnitude of vector. So in shortcut we also call it mod of A. Mod of A means magnitude, and the magnitude is represented by the letter A without any arrow on the top. So when we put the arrow on the top, it is a vector quantity. But when we do not put the arrow, then it is simply the magnitude. So magnitude might be something number, okay, like 10 meter per second. Now there are different types of vectors. We discuss them each one by one. We write down the definition. So first of all, we'll learn about equal vectors, then parallel vectors, anti-parallel vectors, null vector, unit vector, co-initial vector, collinear vector, coplanar vector, and axial vector. Let us look at the definitions one by one. First one. So what are equal vectors? As you can see in the figure, two vectors are drawn. Are they equal? Under what condition they are said to be equal? So the definition says two vectors are said to be equal if they have same magnitude and same direction. Look at the figure. These two vectors are drawn with the same length, so definitely they have same magnitude. Also it is clear from the picture that both have same direction. So these two vectors are having same magnitude and same direction. Thus we can say vector A is equal to vector B. Now since these vectors are equal, I'm talking about these two vectors, okay. Since the vectors are equal in magnitude, we can also write mod of A is equal to mod of B, because mod is the symbol for writing their magnitudes. So when vectors are equal, definitely they have the same magnitude. However, if two vectors have equal magnitude, they need not be equal vectors. Look at this example. Here we got two vectors A and B, both having same length. Both of them are 10 units. So are these vectors equal? Their magnitudes are equal. Mod A is equal to mod B is equal to 10. But we can clearly see that the directions are not equal. So according to this definition, the vector A is not equal to vector B because directions are not same. So whenever two vectors are equal, they must have same magnitude and same direction also. Second definition, parallel vectors. So parallel vectors are vectors which are in the same direction. Two vectors are said to be parallel if they have same direction. There is no constraint on the magnitude. They can have different magnitudes. But only the directions are same, then we say the vectors are parallel. This is the symbol for parallelism of two vectors. Now look at the one more important point to note here, that equal vectors are always parallel. On the previous slide we saw two vectors were equal and they were also in the same direction, so they are parallel also. But parallel vectors need not be always equal. As you can see in this diagram, that these two vectors are definitely they are parallel, but their lengths are not equal, their magnitudes are not equal, so they are not equal vectors. However, if the two vectors were equal, then definitely they will be parallel. Then anti-parallel vectors are those vectors which are in the opposite directions. Look at here, A is pointing this direction, B is opposite to A. And the symbol for anti-parallel is this one. So two vectors are said to be anti-parallel if they have opposite directions. Fourth definition, what is a null vector? As you know, null means nothing, means zero. So a vector whose magnitude is 0 is called as null vector or zero vector. Now let us think about how shall we represent this vector graphically. Can we draw this vector? Can we draw any line which has 0 amount of length? Obviously not. It will just look like a point. So therefore, what can we say about direction? The direction of null vector is indeterminate. Indeterminate means which cannot be determined, cannot be found. Means we cannot say anything about the direction of a null vector. The null vector is represented in this manner, 0 with an arrow over it. This arrow over the 0 emphasizes that we are talking about the null vector or the zero vector. Whereas if you don't put the arrow, only simply 0, then it means you are talking about the scalar 0. What are the applications of null vector in vector algebra? So, a vector minus a vector is definitely 0 or null vector. Similarly, a vector plus 0 vector will be a vector. A vector minus 0 vector is a vector. A vector dot with 0. This is a type of multiplication. A dot 0 is equal to 0. And this is also another type of multiplication. A cross with 0 is equal to 0. We will study in next lecture that there are two types of multiplications for vectors. One of them is called dot product, other is called cross product. Their symbols are dot and cross. So right now we just will note that there are two different types of multiplications, and in each case if you multiply with 0 vector you will get answer as 0. But note one more thing here, this 0 is scalar and this 0 is vector. So actually this dot product is a special type of product in which the final answer is a scalar, and this one called cross product is a type of product in which the final answer is a vector. So more about this later. Next definition, unit vector. Unit, the word unit in mathematics means 1. So a vector whose magnitude is 1 is called as a unit vector. Example, velocity of 1 meter per second or a force of 1 Newton. or displacement of 1 meter, etc. What is the symbol? The symbol for unit vector is the cap. As I told earlier that vectors can be represented by putting an arrow over the letters or a cap. So this is pronounced as A cap, B cap, C cap, I cap, J cap, K cap. So these are this cap symbol is specially reserved for unit vector. Whenever there is a cap over any letter, we must automatically understand that these are unit vectors. So definitely mod of A cap will be 1, mod means magnitude, mod of B cap is equal to 1, mod of C cap is equal to 1. Similarly, mod of I, J, K also equal to 1. So all of these are unit vectors. But we cannot say they are equal vectors because we don't know about the directions. Their directions may not be same. Now what is the formula for finding a unit vector? Suppose this is a vector. Let us say that this vector has magnitude 4. It can have any magnitude. For example, I am saying for the purpose of illustration, let us suppose that the length of this vector or the magnitude of this vector is equal to 4. Now, if I cut this vector into 4 equal pieces, imagine we have a vector of length 4 units. You cut into 4 equal pieces. Then we will get each piece of length 1 unit like this. So I have cut this vector A into 4 equal pieces. So definitely if the magnitude of the vector A is 4, then the magnitude of each of these small pieces will be equal to 1 unit each is in it. So can I say this is 1 unit length means is a unit vector? So all the 4 of them are unit vectors. So we represent like this A cap. So, did we find the formula? So that means if a vector is given and if you divide it by its magnitude, by its own magnitude, then you will get unit vector. So here's the formula. A unit vector can be obtained by taking the vector and dividing by its magnitude. So any vector divided by its magnitude, that means the vector A divided by mod A gives unit vector. Look here once again, the vector A had magnitude 4. So the vector A divided by its mod, that means 4, will give us a small size vector whose length will be 1 unit. And that is the unit vector. So this is the formula for finding the unit vector. An important point to be noted here that the direction of the unit vector will be same as the parent vector A. So I am calling this as the parent, okay, parent, because from this I am cutting into 4 equal pieces. I mean to say that if suppose this vector had length 10 units, so I would cut into 10 equal pieces. Whatever the magnitude, we divide it. So this is the parent vector, and the unit vector will be found in the same direction of the parent vector. Now coming to this unit vectors I cap, J cap, K cap. See here, this is I cap, J cap and K cap. These are very special unit vectors in vector algebra. They are very special place in mathematics. So here what we are looking at a right-handed coordinate system. Look at the coordinate system. It has got 3 axes x, y and z. And here I have represented the vector I cap along the direction of x. Notice the length of the vector I cap. It is 1 unit from origin to here 1. This is number line like 1, 2, 3, 4 number line. So length of the I cap vector is 1. So this is a unit vector. Similarly, the length of the J cap vector is 1 unit. So it is also unit vector. And K cap, the length is also 1 unit. It is a unit vector. So basically, vectors I cap, J cap and K cap are directed along x axis, y axis and z axis. Now, as I said that this type of coordinate system is called as right-handed coordinate system. It is a custom that we will be using only right-handed coordinate system, not left-handed coordinate system in our study of mathematics and physics. Let us understand what is the meaning of the right-handed coordinate system. If you curl the fingers of a right hand, so you take your right hand, okay, and curve the finger, means the forefinger except the thumb. except the thumb, take your 4 fingers together. Curl the fingers of your right hand from the x-axis towards the y-axis. Then the stretched thumb will indicate the direction of z-axis. Let us see this figure. This diagram is representing that this is the right hand, and this is the coordinate system in which we are having x, y and z. You know that x, y, z are mutually perpendicular as shown here. So if you curl the fingers of right hand from x axis towards the y axis, okay, from x towards y, you curl your fingers of right hand, and then the thumb will be pointing in the direction of z axis. This is what this type of coordinate system is called as right-handed coordinate system. You apply on this. Try your right hand. First put all the 4 fingers along the direction of x and curl it towards y, this side. Then you will see that your thumb is coming out of the plane of the screen. So that is the z direction. This z axis is actually perpendicular to the plane of this screen and coming out. Okay. So you curl your fingers from x axis towards y axis. Then the thumb should point outwards. This kind of rule is called as a right hand thumb rule. That means curling your fingers of right hand from x axis towards y axis, and the thumb is giving us the direction of z axis. This is called as right hand thumb rule. Now coming back to our unit vectors I, j and k. I, j, k are unit vectors along the x, y and z direction respectively. So it should be clearly noted that I cap is along x axis, along positive x axis. J cap is the unit vector along the positive y axis, and k cap is the unit vector along the positive z axis. So what will be the unit vector in the negative x direction? That will be minus I cap. The unit vector opposite to this, means opposite to y axis, will be minus j cap, and the unit vector opposite to z axis, backwards this side, back side, will be minus k cap. And also to be noted here that I, j, k unit vectors are mutually perpendicular to each other. As you can see that because x axis, y axis and z axis are mutually perpendicular, and because I, j, k are along x, y and z, so they must be automatically mutually perpendicular with each other. That means angle between I and j is 90 degree, angle between j cap and k cap is 90 degree, and angle between k cap and I cap is also 90 degree. So we call it mutually perpendicular. Now what is the use of these unit vectors? We use the unit vectors I, j and k with cap, of course, I cap, j cap, k cap, to build new vectors. Let us see how we can build new vectors. Look at this. Here I have drawn a vector between 2 and 4. So what is the length of this vector? The length is equal to 2 units. Now because I cap means 1 unit vector, 1 unit. So this vector should be 2 times of this I cap, 2 I cap. So this vector A is 2 times of I cap. Please note it's 2 I cap, not 2 j cap. Why? Because the direction is along I cap. Another example. Let us draw a vector along the y axis, along the positive y direction. How much is the length? 1, 2 and 3. The length of this vector is 3. So what should be the name of this vector? This vector should be 3 times of j cap. Let's say this vector is B. So B is equal to 3 times j cap. Why? Because j cap is a unit vector, means 1 length, and this vector has got length 3. So 3 times of j cap. Suppose I draw the vector in the opposite direction of y axis. So this will be negative minus 3 j cap. The length is the same as 3 only. The length of this vector is 3, but direction is opposite to the j cap. So this vector is called minus 3 times of j cap. Similarly, if I draw a vector of length 2 units in the negative x direction, toward negative direction, or we can say opposite to this I cap, so this vector should be minus 2 I cap. So that is how we understand that the unit vectors I, j and k are used to build new vectors. Similarly, we can also have along the k direction also. Then sixth definition, co-initial vectors. Look at these two vectors A and B. These vectors have been drawn in such a way that their tails are at the same point. So two vectors are said to be co-initial if their tails are placed at the same point. Seventh definition, collinear vectors. In the figure you can see the two vectors A and B are along the same line. So vectors directed along the same line are called collinear vectors. And eighth definition, coplanar vectors. Vectors placed in the same plane are called coplanar vectors. So if you imagine that these two vectors are in the plane, same plane of the paper, then they are coplanar. Final ninth definition, axial vectors. Very important for physics subject. In physics subject, we will study very soon about circular motion or rotational motion. Let us imagine that this particle is moving along a circle. Particle moves along this circle, okay, like this. Suppose the particle moves along a circle in the anti-clockwise sense as shown in the figure. Okay. The straight line passing through the center of circle and perpendicular to the plane of circle is called the axis of rotation. Here, this line you see, the line which is passing through the center of the circle and perpendicular to the plane of the circle, that line is called as the axis of rotation, because the particle is rotating around this line, maintaining the same distance from the line. So that line is called as the axis of rotation. Now this letter omega, this W looks like W in English, but actually this is the Greek letter omega, and the Greek letter omega is used to represent a physical quantity known as angular velocity. You already know about velocity, but here we are talking about angular velocity. Because the particle is moving along a circle, means its angle is changing all the time, so that's why this velocity is called angular velocity, about which we'll study later in detail in the chapter of circular motion. The direction of angular velocity vector is along the axis of rotation, as explained by the right hand thumb rule. So what we need to do, if this is your right hand, okay, so you curl the fingers of your right hand along the circular motion. Particle moves along this circle in anti-clockwise direction. So you take your right hand and you curl your fingers along this circle. Then check where the thumb is going. The thumb will become parallel to the axis of rotation. It will point along the axis of rotation. So the direction in which thumb is pointing, that direction will be the direction of this omega vector, the angular velocity vector. This omega symbol is angular velocity. Even though particle is not moving along the axis, particle is moving along the circle. But it is a custom in vector algebra that the direction of the angular velocity has been taken along the direction of the axis, even though it is not moving along the axis. So these types of vectors that are directed along the axis of rotation are called as axial vectors. Some other examples of axial vectors are angular velocity, angular acceleration represented by alpha, angular momentum, L vector. This is Greek letter tau, which is used for representing moment of force or torque, about which you will study in the chapter of rotational mechanics. So all these vectors have the direction along the axis of rotation. So these are all known as axial vectors. Now, till now, if you have liked the lecture, please press the like button and let's continue the video. Okay, so now it's a little quiz time. So 3 questions. Let us answer these 3 questions before we move ahead to the next topic. So, which of the following statements is true? Equal vectors are also parallel vectors, or parallel vectors are also equal vectors? Pause the video for some time and think about the answer. So if you recall the definitions, you can give the answer that equal vectors are also parallel vectors, but at the same time parallel vectors are not equal vectors. So that's why A is correct and B is wrong. Second question, which of the following quantities are not vectors? So out of these 4, which of them are not vectors? So once again, pause the video and think. So the correct answers are: pressure is not a vector, pressure is a scalar. Work is not a vector, work is a scalar. Electric current is also not a vector, it's a scalar. Force is a vector. So these are the answers. Question 3. Which of the following vectors are axial vectors? So just now we discussed. So here torque is an axial vector and angular momentum is also axial vector, whereas force and linear momentum, they are not axial vectors. Okay, very well. Let us proceed to the next discussion, properties of vectors. So we are going to discuss 5 properties of vectors. First one is angle between two vectors. How do we define angle? And next, what happens when you multiplying a vector by a positive scalar and multiplying a vector by a negative scalar? What is the meaning of negative of a vector? And fifth important property is invariant to translation. Let us see one by one. First one, angle between two vectors. From the first figure, it is very easy to understand that angle between two vectors is say here 60-degree angle, as you can see. So this is vector A and vector B, and angle contained between them is 60 degrees. So we can say, okay, in this figure the angle between the vectors A and B is 60 degree. Look at the next figure. This looks very similar to this figure, but there is a small change here. Look at the tip of the arrow. Compare here. The tip of the vector A is now sitting on the tail of the vector B, and the angle between these two lines is 60 degree. But in this figure, we will say that the angle between A and B is not 60 degree. In the first figure, the angle between the vectors 60 degree, but in the second figure, the angle between the vectors is not equal to 60 degree, because definition is like this. Angle between two vectors is defined as the angle between their directions. So look at the directions. So this line represents the direction of the A vector, and this line represents the direction of B vector. So between these two directions, what is angle? That angle should be 120, not 60. Therefore, answer for this question is that the angle between the vectors A and B is actually 120 degree, not 60 degree. So it's very important to understand, because in case of two lines, it is very easy to calculate the angle or see the angle, but when it comes of vectors, the rules are very strict here. So angle between two vectors is defined as the angle between their directions. Now here you see these two vectors are parallel vectors, and these two vectors are anti-parallel vectors. So angle between parallel vectors is 0 degree, and angle between anti-parallel vectors is 180 degree, because they are opposite. So angle 180 degree. Now what happens when you multiply a vector by a positive scalar, and what happens when you multiply a vector by negative scalar? Let's see. Suppose initially we have the vector A, and we multiply this vector by a scalar number 2. So what happens that we obtain a new vector 2A, whose length will be double that of the initial vector A, and direction will remain the same. So the magnitude of the vector gets multiplied by the scalar number, but the direction remains the same. If suppose we had multiplied with 3, then the length of this vector would become 3 times that of the A vector. What happens if you multiply with negative number? It's a -2. You see, direction got reversed. The magnitude of the vector gets multiplied by the scalar number. That means here the length has become double only. This we multiply by 2. So length become double. But because of this minus sign, direction get reversed. So magnitude of the vector gets multiplied by the scalar number, but the direction gets reversed. What is the meaning of negative of a vector? The first figure shows a vector A, and the second figure shows a vector of same length, same magnitude, but in the opposite direction. That vector is called -A. So negative of a vector is just another vector with same magnitude but along opposite direction. Fifth property of vectors, invariant to translation. What is the meaning of invariant? Actually, invariant means something that doesn't vary, not varying. Invariant means not varying, not changing. Suppose we have a vector A and this vector is translated along this path, any kind of random shaped path, and brought to a new position without changing the orientation, means without making any rotation to this vector. So translation actually means moving without rotation. So imagine that this vector arrow is moved along this path and its direction is maintained the same. After reaching to this new place, did this vector got changed? Is this vector and this vector, they are different vectors or same vectors? So now as you can see, according to the definition of equal vectors, two vectors are said to be equal when they have same magnitude and same direction. Now we translated the vector from one place to another. Definitely it will have same magnitude and same direction. So they must be same vector only. So if a vector is translated from one place to another without changing its orientation or its direction, then the vector remains the same. It is not changed. That is the meaning of invariant. However, if you rotate the vector, then we can say that the vector is variant to rotation. It is invariant to translation, but variant to rotation. If you give any rotation, let us say the vector A is rotated by say 10 degree, 20 degree, then definitely we can say the vector has got changed because the direction will get changed. But when it is translated, it is not changed because we are not changing the direction. So two vectors are equal when they have same magnitude and same direction. Okay, let's move on to the next page. So till here we have discussed here the definitions of vectors and scalars, the representation, how do we represent the vectors, and the types of vectors. So the remaining thing is continued in the next lecture. In the next lecture we are going to study the parallelogram law of vector addition. We study how vectors are added. Triangle law is also another law, how to add the two vectors. So students, continue watching the lectures because the remaining things are also coming up. I hope that you have liked the description of this lecture. Kindly like the video and give your comments. I will reply to them, and also please share with your friends, and please subscribe to the channel. Thank you.